this problem we can look at in a similar way to the first one. We can use some quantitative stuff. We know a speed. We could make up a mass, like 5 kilograms. Since the carts are identical, that would mean each cart has a mass of 5 kilograms. That would mean before the collision, cart X would have a momentum of 10 kilogram meters per second. Cart Y would have a momentum of 0, and we could actually solve for some numbers and determine the velocity that way. Um, but again, it's easier to just think about this qualitatively. So if this is my cart X, it's moving at 2 meters per second. Cart Y isn't moving at all. After the collision, what's going to happen? Well, before the collision, we know there is some rightward momentum. And since momentum is going to be conserved here, it's a frictionless track, we're assuming that it's level. We know that after the collision, P prime should be some positive number as well. We also know that the momentum of each individual cart can't be the same. Okay, when these two carts collide, they stick together. That means cart Y is going to have some momentum after the collision. They stick together, which means if the total momentum is to the right, then both of these carts have to be moving to the right after the collision. And they have to be moving at less speed than cart X was originally, because cart Y originally had 0 momentum. And after the collision, PY has some positive momentum. So whatever the momentum of cart X is, uh, it, um, it has to be less after the collision. Okay, so that means it can't be option A, because option A shows no change in momentum for cart X. And we know that the momentum of cart X has to drop. It can't be option D, because these carts have to be moving to the right. There has to be some positive momentum after the collision. And option D shows no momentum. So it's got to be either B or C. And we can reason our way to realizing that it's C, because each of these carts has the same mass. Each of these carts is going to have the same velocity. That means each of these carts must have the same momentum. Okay, and um, and uh, and so with the same mass and the same velocity, if they have the same momentum, we can't see a drop of just 1/2 meter per second for cart X, because that means cart Y is going to be going at 1.5 meters per second. So cart X drops by 0.5 meter per second. Cart Y gains by 1.5 meters per second. And we're going to end up with more momentum than we started. We can't have that. The total momentum can't be 1.5 plus 1.5 times the mass of cart X plus 1.5 times the mass of cart Y. That's going to give us um, that is going to give us effectively a third again the amount of momentum that we started with. So this is the only way that each cart can have the same amount of momentum, yet the total can still be the same before and after the collision. Cart X must have lost half its momentum, and cart Y must have gained an equal amount. So we could reason our way to it. If you wanted to, you could also have just said, well, let's just say the mass is 5 kilograms. If we do that, then you can actually figure out that in case B, for example, cart X would have had 5 times 1.5, cart Y would have had 5 times 1.5, and that's going to give you a total of 15 kilogram meters per second when we only had 10 kilogram meters per second to start with. So it has to be C. No matter how you do it, you end up with option C as the only possibility.